Greetings, Earthlings! Welcome to Science with Sophia, the show where we teach you skills to help you improve your abilities in math and science. So, today we are going to be talking about the bane of math and science students everywhere. That's right, word problems. Of course, the million-dollar question: why are word problems hard? Well, I got a few different ideas. First of all, we don't have much practice combining our verbal and analytical skills on a daily basis. In English class, we learn verbal skills, and in math class and science class, we learn analytical skills. Word problems are really the only situations where we're required to put the two together, so doing that when you don't do it very often is hard. We learn how math procedures work, but not how those math procedures apply in real life. Math is very abstract. Most of the math we learn is just X's and Y's and ones and twos and zeros up on a board. Learning how to apply those abstract concepts to the real world when you don't have a lot of practice doing it can be really frustrating. We practice memorizing solutions instead of learning how to come up with solutions of our own. Oftentimes what happens is when we get a problem, we learn, how the professor or the teacher does it on the board. We don't really think, oh, I can do this on my own. I can come up with a procedure on your own. Well, in a word problem, they don't hand you the solution right away. They expect you to come up with the procedure. And coming up with a procedure is really hard if you haven't done it before. We might feel confused as to what each number represents. A lot of times in word problems, we have a lot of information we got to keep track of. Knowing what each number represents and how to use it can be really hard. But thankfully, there is a way to get around all of those problems, and I call it the word problem magic formula. So, how does the word problem magic formula work? Well, the word problem magic formula is a methodology that requires you to sit down and think about what it is the problem is asking and what it is the problem requires you to do before you begin your math. And here are the steps. So we got step number 1. First step we do in any word problem is we draw a picture. Sometimes the picture isn't always obvious what we need to draw, but that's the first thing that we do. Second, we list all the numbers that a problem gives you. Third, we list all the numbers that we are required to find. This includes things that the problem asks for directly, as well as things that might help us get to the end point that the problem doesn't necessarily ask for specifically. Fourth, we list any formulas or equations that we have that might help us to get to our answer. And then 5, after we check that we have everything we need, in steps 1 through 4, then and only then do we actually do our math. Okay, let's talk a little bit more about what each of those steps of the word problem magic formula entails. Step number 1, draw a picture. It is difficult to figure out what is going on in a word problem unless you can visualize it. Draw a picture or comic strip of what the scene describes in the paragraph. Charts, graphs, diagrams, and stick figures all count. Whatever helps you figure out what the heck is going on. That's what you need to draw. Make sure you label things in your picture with the numbers you are given in your word problem and the numbers you need to find. Step number 2. Write down every number they give you. A big challenge of word problems is keeping inventory of the information we're working with. That's why as soon as we're done with our picture, we write down the numbers we're given. Go through the paragraph with a highlighter or a pen and highlight every number you see. Then write it down. The goal in this step is to be as specific as possible. We write down the number. We write down the units that go with that number, whether they be feet or inches or liters or widgets. And we write down exactly in 2 or more words what that number represents. We don't just write down feet. We don't just write down length. We write down length of the garden or initial volume of water, or number of bears in the woods. So you got to be very, very specific. Step number 3. Write down every number we need to find. Identifying what numbers we need to find is just as challenging and important as making sense of the numbers we're given. This step actually has 2 parts. First, identifying the numbers we need to submit as the answer to the question. And 2, identifying any numbers that might help us get to our final answer that we don't currently have. To find the numbers we need for our final answer, what we do is we scan the word problem and highlight any question words we see, such as what, or where, or how much, how long, how many. Then what we do is we write down what those question words are referring to. And again, our goal is to be very, very specific. We write down what units go with that unknown number, and we write down in 2 words or more exactly what that unknown number represents in our story. For the second part of step 3, we write down any numbers that we don't currently have that may help us get to our final solution. For example, if we're trying to find parameter, it might be helpful to know things like area, or radius, or length. So we'll write those down as unknowns. So this is a brainstorming step. So we brainstorm for any numbers you can think of that might be helpful. You may end up not needing those numbers, but it is still helpful to come up with possibilities so you can better plan how you do your math later on. And again, in this step, we need to be specific. We write down the units that go with those unknown numbers, and we write down in 2 words or more what those unknown numbers represent in our story. Okay, nerds, we are about halfway done at this point. The worst is behind us. But let's move on to step 4. Step 4. Write down any formulas that might help us. So, I guess a good question to start would be, where do we get our formulas? Well, if you are studying at home or you're doing real-world science, you can always look for your formulas in your notes, in your textbooks, or look them up on the internet. If you're taking a test, your teacher might ask you to memorize those formulas, or they might allow you to bring a formula note card into the test with you. Another important question you might be asking, how do you choose which formula is best? Well, what we want to do is we want to look for formulas that contain variables represented in our list of known numbers and variables represented in our list of numbers we need to find. For example, if in my knowns I have area of a circle, and in my unknowns I have the radius of the circle and the diameter of the circle, I know that I need a formula that can link us between area and radius, or between radius and diameter. If, for example, again, in my knowns, I have the speed of a train and the time the train travels, and what I need to find is the distance the train travels, I know I need a formula that contains speed, distance, and time. The ideal formula is one that has only one unknown, but if you do get a formula with 2 unknowns, for example, in this case, I don't have moles or molar mass, then what we can do is we can add that second unknown into our list of things we need, and we can add a formula to find that second unknown into our list of formulas. Keep in mind, you may need to construct a formula for yourself. This may happen if the exact scenario presented in the problem is not represented in your book or your notes. Sometimes the word problem itself doesn't want a number for its answer, but instead is asking for a formula of your own construction. If this happens, keep in mind some base formulas or component formulas that might be useful. For example, if we want to use volume and concentration to find the product mass of a chemical reaction, we can remember component functions like moles equals mass divided by molar mass, and concentration is moles divided by volume. We can use this to construct a formula to find our final answer. Or say we see a problem mentioning a steady rate with respect to time. We can remember the basic structure of a linear equation, y equals mx plus b, and use it to construct an equation with the information that we have. Okay, so we've finished step 4. At this point, many teachers might actually let you turn in everything you've written so far for partial credit, but we're going for the gold medal. However, we don't want to move on to step 5 just yet. Now we want to pause and make sure we have everything. We've made our lists, now let's check them twice. So first thing we want to do, we want to read through the problem again to make sure we know exactly what we have and what we're looking for. Next, we want to compare our formulas to our knowns and our unknowns and see if we need to add anything to our stuff we need to find list or add any formulas. We want to consult our picture to see if the information we have listed in steps 2, 3, and 4 match what's going on in the picture. We want to make sure all our units are attached to our known numbers and our unknown numbers, and to make sure that they're correct. We want to make sure that all the numbers we have written down are correct and correctly correspond to what they represent in the story. We do not move on until all our T's are crossed and all our I's are dotted. So, we finished steps 1 through 4, and we've checked them over thoroughly. So, let's move on to step number 5. We do our math. Now, I'm going to make another video in the future that explains good math habits, but the main good math habit to remember when we're doing word problems is we leave our units attached. So when we plug our numbers into our formula, we write our units next to our numbers, and we leave the units attached to the numbers through every step of the writing and the algebra. This is so that we can remember what every number represents as we work. Here's an example using velocity, distance, and time. Say I want to solve for time. So watch how I write my math so that I can help myself keep track of what I'm doing. So, okay, distance is 100 meters equals 7 meters a second times time. Okay, yeah, leaving it all on there. Let's see, divide both sides by 7 meters a second, so I'm even writing my units in here when I'm writing it under the division line. So I get 100 over 7. Okay, meters cancels. Seconds moves up to the numerator. So 100 over 7 seconds equals time. The goal of that is to allow us to cancel our units and watch our units fit together so that at the end of the day we can make sure that we have the right unit attached to the right number and we have the right number that we're solving for, and that can help us connect it back to what's going on in our story. Okay, here is a seasonally appropriate example. Santa is calculating how many toys his elves need to make before Christmas. He estimates there are 1.9 times 10 to the 9th children on Earth. Each child needs 3 toys. How many toys must he order from the workshop? Okay, so I remember that my first step was to draw a picture. Now, let's see, how can I draw this in a way that will help me to understand it? Well, maybe these dots will represent the children. I can't obviously draw 1.9 billion, but and each one will obviously get 3 presents. So those little boxes can represent presents. Yeah, so I can see sort of what's going on when I draw it like this. Just a very simple little cartoon to help me figure out what is happening. Okay, so after I draw my picture, it's time for me to write down all the numbers that I'm given. So I'm going to read through it again, and I already underlined them for ease of reading, but what I would do is I go through with a highlighter and I highlight all the numbers that I see. And let's see, 3 toys. And then I can write those down. And remember, we write down what the number represents in 2 words or more, and what units go with those numbers. So we got children on Earth, and that is equal to 1.9 times 10 billion. Children, I'll just use C for children. I got 3 toys. Okay, 3 toys per child. So toys per child equals 3 T over C. And those look like all of the numbers that I am given. And my next step is going to be to write down the numbers that I need. So again, I'm going to go through it with my highlighter, and I'm going to look for question words, okay? And I see, oh, how many toys his elves need to make. And then I see my question mark here. How many toys must he order? So I need toys in total. So toys in total is the thing that I need. And that, of course, is going to be in units of toys. Okay, but I'm not quite done with my needs section yet. I need to also look through to see if there's any other numbers that might be helpful to help me figure out my final answer. Let's see. It doesn't look like there are, so I think at this point we might be good for our needs section. Okay, at this point we can start to write up our formula. Alright, so does it give us a formula? Well, it gives us some information, but it doesn't give us a formula. So we're going to need to make the formula ourselves. So let's look back at our picture. Maybe that can give us some clues. Well, I have my dots representing my children, and my boxes representing my toys. So it looks like that each child gets 3 toys, which means that I'm going to need to solve this by multiplying. So let's see. So number of toys total is going to be equal to, oh, not total, it's total, number of toys per child times number of children. Alright, so at this point I want to double check. Okay, do I have my picture? Yeah, do I have all the numbers that they give me? Yep, I got the 1.9 and the 3. And I got those units, children, and children per toys. Do I have all the numbers that I need to find? Yep, it looks like it. And do I have my formula? And I want to double check to make sure that my numbers that I have, so children and toys per children, those obviously match up with my formula, and the number I need to find goes in there as well. So it looks like I might be ready to do my math. Okay, so math time, math time, math time. So I'm going to plug all these in. So this obviously is going to be an unknown. Number of toys for children, that was 3. And look, I leave my units attached while I'm doing my math. And 1.9 times 10 to the 9th children. Okay, so let's do that math here. So 3 times 1.9. I don't have that memorized. So I'm going to do it the old-fashioned way. 3 times 9 is obviously 27. Carry the 2. So 3 times 1 is 3. So that will become 5.7. So my answer is 5.7 times 10 to the 9th toys. Oh, and I can see that it's toys is going to be my final unit because children cancel. And there we go. We did it! We just solved a word problem using the word problem magic formula. Thanks for watching, nerds! Hope you have a happy holidays and good luck with your math classes this year. Bye!